Welcome to The Explainer. Today, we're diving headfirst into managing the sheer chaos of large-scale distributed applications running on AWS. If you work with cloud infrastructure, you already know the struggle. Keeping everything running smoothly, it's kind of like trying to conduct a symphony where every single musician is sitting in a completely different room. It's literally the ultimate headache for DevOps engineers, right? You get an alert that something is broken. But how do you trace a single failure across a massive, highly distributed architecture? How on earth do you figure out if it's an ECS Fargate container, a serverless Lambda function, or just a bad database query causing the bottleneck? Well, stick around because today we are exploring the exact tool stack to solve that specific nightmare. So here's our roadmap for today's explainer. We'll be hitting 5 main stops: discovering application signals, visualizing with application maps, integrating OpenTelemetry tracing, setting service level objectives, and then we'll tie it all together by resolving real-world issues. Sound good? Let's get right into it. Section 1, discovering application signals. Let's start right at the foundation. Meet CloudWatch application signals. Honestly, think of this as an automated watchdog for your cloud environment. Historically, getting visibility into your apps meant writing heavy, tedious custom code or wrestling with complex third-party tools. But application signals, it automatically collects telemetry data right out of the box from your applications running on EC2, ECS, Fargate, and Lambda. I mean it. You literally don't have to write custom instrumentation code to get this up and running. It's a total game changer. Once it's running, it instantly gives you visibility into your operational health by automatically pulling 5 vital metrics. You get call volume to see how many requests you're handling. Availability tells you what percentage are actually succeeding. Then there's latency, how long they take, along with faults for application-level issues and errors for failed requests. Basically, this gives you an immediate, crystal-clear baseline for understanding exactly how your system is performing. Moving right along to Section 2, visualizing with application maps. Because, raw numbers are great, but seeing exactly how they all connect, that is even better. With automatic service discovery, there is no more guessing how your services actually talk to one another. Application Signals maps your entire application topology in real time. It actively figures out how your Lambda functions call your ECS containers, which databases they're hitting, and the external APIs they rely on. You get an always-on visual catalog of your architecture, and get this, it even spans across multiple AWS accounts within a region. Now, instead of staring at a giant, noisy spaghetti web of lines, you can dynamically filter this massive map to fit exactly what you need to see. You can filter by environment, like isolating production from staging. You can look at related services to see an automatic cluster of dependencies, like Service A calling Service B. Or you can use custom groups. By leveraging AWS tags or OpenTelemetry attributes, you can view your architecture by specific business units or development teams. It really cuts through the noise. All right, Section 3, integrating OpenTelemetry tracing. We've got the macro view, so now let's dive into the micro, code-level details. The distinction here is absolutely crucial. Standard AWS metrics tell you that something is broken. They let you know, hey, your Lambda function is slow. But OpenTelemetry? That's an open-source observability framework that tells you exactly why it's broken. It instruments your code to trace the exact flow of a single request, letting you pinpoint the specific custom business logic, or the exact database query that's causing that massive latency spike. And setting this up for serverless functions is incredibly streamlined. You don't need to rewrite your whole app. Just follow 3 simple steps for Lambda. First, attach the AWS distro for OpenTelemetry Lambda layer. Second, set your essential environment variables, like your OTel_service name, so you can actually identify the service in your traces. And third, inject custom spans into your code to track execution times for your most critical business operations. Boom! Complete end-to-end code-level visibility. Which brings us to Section 4, setting service-level objectives. Because having a mountain of metrics doesn't mean much if you don't know what success actually looks like, right? To truly maintain reliability, we have to tie our technical data back to our business commitments. We start by measuring an SLI, or service level indicator. That's just your raw performance metric, say measuring that your latency is at 200 milliseconds. Then we compare that SLI against our SLO, the service level objective. The SLO is your actual attainment goal. It's the promise you make to your users that your SLI will meet a specific threshold over a set period of time. Now, you could actually calculate these objectives in 2 distinct ways, depending on how your application runs. Period-based SLOs evaluate performance over discrete chunks of time. For example, demanding that your application is fully healthy for 99% of all 1-minute periods in a given day. Request-based SLOs, on the other hand, look at raw user interactions. They measure the pure ratio of successful requests compared to total requests over that interval. Let's talk about the number 99%. This single number represents a typical, strict attainment goal your ops team has to hit. If you have an SLO of 99% for availability, you are mathematically committed to successfully handling requests 99% of the time. But what about that remaining 1%? Well, that remaining 1% is your error budget. Think of it like your monthly cell phone data plan or literal cash in your wallet. It's the allowable downtime or failure rate you are spending before your system violates its overarching contract. As long as the consumed budget, what you've spent, doesn't eat up the remaining budget, you are successfully meeting your business commitments. And this is where burn rate comes in to save the day. If your burn rate exceeds 1, you are essentially bleeding cash. It means you're burning through your error budget way faster than your baseline allows. Keep that up, and you'll go completely bankrupt on your reliability commitments. But the cool part is, Application Signals lets you set up automatic CloudWatch alarms. So the moment your burn rate spikes, your team is alerted well before the total budget runs dry. Okay, Section 5, resolving real-world issues. Let's pull all these abstract concepts out of the clouds and into a practical scenario with Jane. She's an engineer on a DevOps team running a distributed pet clinic application. So Jane gets an alert for an unhealthy SLI. Instead of panicking and digging through a dozen different log streams, she just opens CloudWatch. Instantly, the application map highlights that her visit service is experiencing a massive fault rate and volume spike. She clicks on that service, opening a drawer of OpenTelemetry traces. Following the transaction search right down the call path, she sees exactly what's failing. It's a DynamoDB table throwing errors. Why? Because its provisioned throughput was being totally exceeded during the traffic spike. By using application signals and traces together, Jane went straight from a high-level alert all the way down to a misconfigured DynamoDB table in just a few sequential clicks. They bump up the throughput, and the app is completely healthy again. And that perfectly captures why this is such a big deal. CloudWatch Application Signals collects and organizes all that telemetry data, while OpenTelemetry provides the deep instrumentation. Together, you get total production-ready visibility across your distributed systems, from high-level business goals down to a single line of code. And the best part? You do it without the traditional nightmare of managing complex tracing infrastructure all by yourself. Thank you so much for joining this explainer. I want to leave you with a final, provocative thought to ponder about your own cloud environment. When things inevitably go wrong, are you just guessing in the dark? Or are you charting a direct, clear path to the solution? Could your current observability stack resolve a critical latency spike that effortlessly? Think about how these tools might completely change the way your team operates. Keep learning, keep building, and we'll see you next time.